Hello everyone, and welcome to our engineer interview this week with Ian Cameron. Now, my name's Scott and I work at Primary Engineer. Before we start, I would just like to say a massive thank you for signing up to this year's competition. It's our 10th birthday this year, so thank you all for celebrating it with us. Now, for those of you who don't know, this is the Leaders Award competition, and this is where we ask the question, if you were an engineer, what would you do? Pupils from the ages of 3 to 19 anywhere in the UK can join, and every single person who takes part gets a graded certificate from a real-life engineer, just like the ones we interview. We then host public exhibitions in May at the end of the school year to celebrate all the amazing engineering ideas of the pupils who took part. Now, we can't wait to see all of your amazing and creative ideas, and you're going to get some added inspiration today from our special guest speaker. Now, as part of these interviews, we're going to be speaking with engineers who work on loads of different projects, all of them showing the wonderful, interesting and exciting things that happen when you work in engineering. Although we host these interviews live, you will be able to catch the recorded versions on our YouTube channel. Now, our special guest is going to start with a 10-minute presentation all about taking hydrogen from water and why that's going to change the world. And then we're going to open up to questions from the audience. If you would like to ask a question, simply type it in the chat function in Teams. We unfortunately can't receive audio from the audience, so if you do have a question, just type it in there. But for now, I'm going to hand over to our special guest, Ian Cameron.
So as Scott said, I am going to talk about how we extract hydrogen from water and why it's going to change the world. So firstly, there's going to be a little bit about me. So I am an engineer. My title is Hydrogen Technology Development Engineer, which is quite a long mouthful, but I'll try and get to the reasons of that. But I'll take you back to kind of my school days. So in school, I was your kind of stereotypical geek, so to speak. So I enjoyed science, maths, computing, and art, really. So when it came time to think about what I wanted to do at university, kind of mechanical engineering and physics were the two things that kind of came to mind. But with my art side of things as well, it really did push me down the road of mechanical engineering. So I attended the University of Glasgow, where I first did a mechanical engineering degree. So that is very focused on kind of how things work and why they work and why you want them to work. So that could be anything from heat and temperature to engines to planes, that kind of thing. And that kind of did take some of my art into it, because in that degree, there was very much a lot of drawing, kind of sketching, understanding how things work. So you would sketch them to understand how forces worked, how things worked, how essentially pieces fit together. And I loved it. It was brilliant. And I also did a physics with astrophysics degree. So that is quite a bit different, because that was on the physics side, kind of pure science. So that was looking at instead of how things work, or maybe it was how things work, but at a lower level. So how atoms work and how kind of those pieces fit together, how light works, all those amazing things like that. And about a quarter of that degree was astrophysics. And that was very much looking up into the sky and understanding what all these things are, what stars are, what our universe is, why is it expanding, all kinds of things. And that was brilliant, because on one side you have the mechanical engineering degree, which is essentially how things fit together. How can you make things? How you can kind of you'd make things happen, to physics, which was the kind of underlying why does this happen? Kind of physics is essentially the study of nature and everything that actually the kind of lower levels of things and the incredible kind of science beneath everything. And kind of both together kind of really helped me be the engineer I am. But that kind of takes me on to my career. So when I graduated, I joined a company called ST Microelectronics. Now, this is a vast company all over the world, but my little division of it was the imaging division. So that essentially was cameras And in my case, it was camera phone cameras. So I was responsible for the testing of camera phone cameras. And if you can imagine, people like Nokia, Samsung, and Apple, they have multiple cameras in their phones these days, and you have to test millions of these things a day. So if if the lenses are slightly out, if the software controlling them is slightly out, you have problems. So it was a massive kind of machines you would use to run millions and millions of these cameras through, test them, move on, test them, test them. And a lot of these factories were out in China. So I spent a lot of time in China and Singapore. And that kind of gets on to one of the reasons I really like engineering is because you can take it anywhere in the world. Engineering doesn't change, science doesn't change around the world. So if you have a skill, you can take it anywhere. And after ST Microelectronics, I moved to a company called Peak Scientific, where I am now, and I worked within the hydrogen team. So the hydrogen team from Peak Scientific make machines that turn water and electricity into hydrogen, and then the user of the machine uses that hydrogen for whatever they want. So various things are laboratories, making diamonds, industrial diamonds are another one, but it was a kind of a big segue from the optical side of things, the camera side of things, to kind of the gas generation hydrogen side of things. So you would take a lot of learnings you would have, and as I said, engineering doesn't really change. You can take one part from one place and take it to a new industry without much problems. So kind of our biggest achievements in engineering so far is very recently the department I work in, just won the Scottish Engineering Award Best Engineering Company. So that was a kind of massive thing because it's something we've kind of been working towards and something we've been pushing. The next thing on the design side of things, which I really focus on, is we invented the smallest hydrogen generator on the planet. Now, I tried to get a video of this, but there's not that many out there that's particularly good. But if you can imagine, the same size as about maybe that size by that size by that size, tiny little hydrogen box that has nice bubbles in the front, and you just put it on your desk, you put water in it, you put electricity in, and that makes hydrogen. And like it was a big development, and like we're all very proud of it because it is quite cool looking. Now, the reasons we want to make hydrogen, I'll move on to. So first off, what is hydrogen? So hydrogen is the most abundant element in the universe, so by quite a margin. So about 90% of all atoms in the universe are hydrogen, but you don't actually find it on Earth very much. It's always bonded to other stuff, so hydrogen and water, say, because hydrogen gas is very light and very buoyant. So when you create a hydrogen gas, it very quickly escapes into the atmosphere and disappears into space. So that's why you don't find hydrogen very often. But one of the things we use hydrogen for, and I'll jump onto it in a second, is for something called electrolysis. So using electrolysis, you can create hydrogen and oxygen out of water. But this is something that came about hundreds of years ago. And as some of you may know, Jules Verne, he was an author. He was actually talking about how hydrogen will one day be used as a source of energy. So, and energy and fuel. And this was postulated 200 years ago. It's incredible. And nowadays, this is what electrolysis is. So you probably know that water is made up of two things, so hydrogen and oxygen. But you can provide electricity to water and it splits. So you get hydrogen on one side and oxygen on the other side. Now, why is that interesting? Well, you can actually do something like this. So if you can imagine you have offshore wind, so wind turbines getting blown, turning, creating electricity, you can then put that electricity into the water. You can create the oxygen and the hydrogen. Then you can take the hydrogen out and start storing that somewhere. So that'd be big canisters or kind of big fuel systems. You could then pipe that into homes and you can burn that for heat. You can use it for gas stoves, that kind of thing. And when you look at that, that becomes a completely renewable system. Because one of the cool things about hydrogen is you can recombine it with oxygen in a fuel cell, which is kind of the opposite of an electrolyzer, and that becomes water again. So it becomes very cyclical. So imagine that we just wouldn't need natural gas anymore. We wouldn't need batteries here. It's all stored in hydrogen. It's all directly from renewable gases. So I've got kind of a few pictures of why other hydrogen things are cool. So in the submarine in the top left and the astronaut in the bottom, they use electrolysis for a slightly different way. So they take the water, they put in electricity, and they just get rid of the hydrogen and use the oxygen for breathing. So they combine it with other things and you can breathe it. Then you get to the car in the bottom. So it's a very big thing right now to try and use hydrogen to power cars. So instead of filling up with petrol, you fill up with hydrogen, and then instead of filling up with electricity for electric cars, it would be hydrogen. So that would be hydrogen then uses a fuel cell, turns that into electricity and water, and you have power for your car. The other things are shuttles. So with hydrogen, you can turn it into liquid hydrogen, which essentially you squeeze it very tight, and eventually becomes a liquid. And it's very dense and a lot of energy involved. And NASA uses it to power their space shuttles and their rockets. So that becomes rocket fuel. The next few things that haven't actually happened yet, but are in the process of happening, is the hydrogen airplanes. So one thing you'll note is Airbus is a big company that creates and build airplanes, have a very big project in making new planes. But because you have to store so much hydrogen in the plane, the shape of it changes quite a lot. So if you see in the bottom left-hand side, that'd be Airbus's zero emission plane. And you can see it's a very odd shape, but that's because you have to cram in hydrogen gas in there somewhere. So the kind of system changes. And the last one I'm going to point out is transporting liquid hydrogen is now becoming a thing. If you look in those big spheres on top of that boat, that is all liquid hydrogen. So imagine you can create hydrogen somewhere, compress it right down, put it on a boat and ship it anywhere in the world. And it becomes essentially what natural gas is today. We can use hydrogen and it's completely renewable.
Ian, thank you so much. That was fascinating. I have a question for you, Ian.
Sure.
What do you love about your job?
So I suppose two things actually. One is I love designing stuff and I love inventing stuff. And there's not a lot of jobs that you can come in, come up with a good idea, and actually by the end of the day, go down to your lab, build it, and kind of hammer it all together, or 3D print it, or do something, and you actually get something at the end of it that you can test and you can take home and you can tell people about, and it actually becomes, you can patent it and invent it, and it's incredible. The kind of second thing would be the people. Like so many people in engineering, there's so many different types of engineers, but there's so many types that are so passionate about what they do. And you come in with an idea and someone tells you your idea is terrible, but then you kind of move on and you kind of brainstorm. And at the end of it, you have something that's really cool, but it's something that you couldn't have done by yourself. So it's all collaborative. It's brilliant.
Yeah, I think what I get the most from doing these interviews is finding out about all the cool people that engineers get to work with. And it sounds like you have to work as a team. And Mrs. Henderson's got an interesting question about that. Have you ever had something at work which has been a mistake and gone wrong? Now, you mentioned that you sort of do it with a team and sometimes you learn from it. But yeah, has anything ever gone wrong?
Oh, absolutely. Things go wrong all the time. So certainly with hydrogen, I might not have touched on this, but hydrogen is very explosive. So in our kind of lab, we're fairly safe, but the amount of hydrogen used are fairly small. But things go wrong all the time. We probably do more testing. We never really get to the stage something is wrong and we haven't learned anything from it. It's more something's wrong and you go, okay, I thought it would be right, but it's wrong. So why is that? And then it's a process of trying to more understand what has gone wrong and why.
So would you say that's quite an important bit about being an engineer is testing things, and when they go wrong, it's not always bad. You can actually go, oh, why did it go wrong? Let's make it better next time.
Yeah, I suppose it's kind of the scientific method of it. Like not all failures are bad things. In fact, in engineering, a lot of the time, failures aren't bad things. You will always learn something from it. And that's why even in my team it is if something has gone wrong, like don't try and hide it. That's the worst thing you can do. Let everyone know. And then each other person will learn from that. And the next day something better will come of it.
All about working as a team. I love it.
Yep.
So just we've got a question here as well, and it was about. So you mentioned that you went to study at university, and it means that you could involve your love of physics, but also art. But what about earlier on? What was it that inspired you to be an engineer?
So I think it was kind of my love of kind of breaking things down and building them up. So I was always the kind of kid that would try to understand why your TV worked, understand how your car worked. And it was essentially my mum that kind of pointed me in the way of engineering. And she was a biomedical scientist, and she loved it from that point of view. But I wasn't so good at biology, so I was like, I can understand kind of engineering from this point of view. And is engineering is just so varied and interesting that as an engineer, you're never going to become this perfect engineer because there's so much out there and so much to learn.
So yeah, you said that engineering is so varied, and you said what you started working on versus what you're doing now is completely different. So what
Yeah.
was the first project you worked on?
It was actually something for Apple, the Apple phones. So we were making a little laser rangefinder for phones, and I needed to make a kind of desktop testing device. It doesn't sound very cool, but it was. There was a lot of there was a box and a lot of levels kind of moved into place and a lot of different lighting conditions, and you would shine it, and it would try to test this little laser rangefinder in all sorts of different light levels and kind of ranges and all sorts. And that gets shipped out to Apple, and it all worked, and it was great. But it was very, very nerve-wracking because obviously Apple's a massive company, and I
Yeah.
had to stand up in front of them and try and explain the reasons I'd done something.
So have you held an iPhone before and known that the things in that is what you helped make?
Yes, I have indeed.
That's pretty cool. So we've got some more questions coming in about the projects you've worked on. This question comes from Abby at Wellshot Primary. What do you think's the best thing you've ever done or made?
Good question. The best thing I've probably ever made would be the Precision SL, which is a very small hydrogen generator, because that involved essentially shrinking everything down. And it was something I'd kind of toyed with in my brain, but I managed to kind of get a week free in my work, and I went into the lab and started kind of banging things together and kind of screwing things up and designing stuff. And eventually I got something that was kind of fairly large into this really, really small little thing, and it works perfectly. And it's just it, and it kind of the feedback you get from it is really positive, and just knowing that is good. That is just
Yeah.
really feels good.
And it helped you win an award as well. That's
Did
always
indeed,
handy.
yes.
So we've got another question from Gavin, and Gavin's asking, what project are you working on right now?
Uh, some fairly secret projects at the moment, but I can
Ooh.
say I can tell a bit of about stuff. So we are working on a couple of things. So we are working on much larger hydrogen generators, so larger flow, larger pressures. We're also working on ways to recycle the oxygen coming from the electrolyzer cell. So right now we don't really use the oxygen for anything, but in some scenarios it is useful. So that involves kind of reworking our entire system. That we are very good at collecting hydrogen, but we needed to really learn the kind of safety implications, the kind of design implications of collecting the oxygen as well. And it is good, quite honestly.
So that's something that we can keep an eye out for in the future.
Absolutely. Yes.
So we've got another question in here, and this one's from Mono Primary School, and Khaled asks, how does the water create electricity? Because I'm the same, Khaled. I don't know how that works. Water, don't get electrics near it, but in actual fact, you can use it to help with electricity.
So there's kind of two things around it. So the water you can split using electricity. So you pump electricity into water there's a few kind of elements to it as well. And on one side, on the cathode side, you get hydrogen. On the anode side, you get oxygen, and then you collect them. On the other way around, you use a fuel cell, which is essentially the reverse of that. And you combine very pure hydrogen and very pure oxygen, and essentially recombines it into water. And when it recombines it into water, that is what produces your energy. And you take that away and use the energy.
So it's almost like putting two things back together, produces this bit, and you capture it, and then we can use it again. Oh, fascinating. So that sounds like it's, like you said, changing the world, and it's something that we've not been able to do before, especially not years ago. And Roxanne asks, how far away are we from being able to use hydrogen in everyone's homes?
So there's projects even in the UK right now, and probably fairly close to all the guys at the moment that are on the call, that there's tons down south, there's tons in Scotland, and it is essentially trying out these new systems in houses. So some villages are actually, I think at the moment, maybe not full villages, but definitely houses are working with 100% hydrogen right now. And you just see more and more projects coming along with the same thing. So even near me in Glasgow, we have a massive wind farm called Whiteley, and they've just built a electrolysis system to create hydrogen from the cheap renewable energy that's doing. So it's going to be quicker than you think that it's going to happen. There's certainly houses right now that are running on pure hydrogen.
That is quite exciting. So, how important is hydrogen to helping with climate change?
Massively. So there's always kind of this rivalry between kind of electric kind of battery cars and hydrogen powered cars. And it's always kind of the kind of rule that if you can do something directly with electricity, do that because that's the most efficient thing to do. If you need to store it, that becomes when it becomes a bit more complicated. So batteries, they only work for a while. They need quite a lot of kind of intensive manufacturing materials, whereas hydrogen is a bit more simple. It's essentially use this electrolyzer, turn the water into hydrogen gas, and then use that hydrogen gas. There's a lot of engineering complications to overcome, and that's why I love working in the industry. But if it works, and I believe it totally will work, it's going to be absolutely massive. Because imagine cheap energy, free energy from renewables, to turn that directly into hydrogen. When you need more energy, you can turn that hydrogen back into electricity. It's brilliant.
That is pretty amazing. We've got some more questions coming in here. Remember, if anyone's out there sitting on a question, you can type it in using the chat function. This question comes in from Tyler at Mono Primary School. And Tyler wants to know what's been your favourite project. We heard about some of the best ones and the award-winning ones, but what's been your favourite?
I am working on something right now that it's not kind of how to describe this. It's actually no, I'm going to change that. I'll go back to my old job because I don't know if I was allowed to tell you about that. But so with ST Microelectronics, I needed to go to China, and this was the first time I'd been in China. The first time I'd really been away for like a work trip, and this was like 3 weeks of work. And I was introducing a new test system that I'd created into the factory. And the factory was 1,000 people. It was a massive, massive place. And it was only me that went across. And a lot of the guys out there, brilliant English, and my kind of Mandarin was not brilliant in any way, shape, or form. And I worked with these guys and we got really close because I was there every day. And even though we might not all of us kind of spoke English or Mandarin, we could still work together to kind of integrate the system into the wider factory. And it was just the kind of culture shock of, you know what, I can do this. I can actually go out there with a limited knowledge of Mandarin, but actually the engineering side of things clicks and it works and everyone kind of gets to work it. So it's brilliant.
Yeah, that must have been pretty special to work on. The sort of, it's almost like you could talk to each other doing engineering rather than the language.
Yeah, okay.
We've got another question in here from the same primary school, and it's from Alicia. And Alicia wants to know, how long can a project last?
So it varies quite a lot, actually. So say you come in with a good idea one day and you take it to the owner of the company, say, and they say that's brilliant. You could make that change in a few weeks, say. Whereas we have other projects that are kind of products from scratch that would take 2.5 years, that kind of thing. Like, so at the end of it, there is a lot of kind of safety testing that needs to take place just to make sure your product is kind of fit to be sold.
Well, when you mentioned that hydrogen can be explosive, I'm glad to hear there's lots of safety that goes
Absolutely.
in. So as projects, big or small, can last as long and short as they can, there's a question from Josh at Wellshot Primary, and Josh asks, was there a project that you got to start but never got to finish?
I'm sure there must be, but I can't think of one right now. No, I don't know. I think I have somehow managed to finish all the projects that I have started.
You've done all your homework then, Ian, is that it?
I hope so, yeah. There's probably a massive project that I've forgotten about somewhere, but it's still there.
So we've got another question here from Mono Primary, and Harley is asked, what's the most ambitious project you worked on?
So I suppose it is this project I'm working on right now. So this is one of these from scratch products. And essentially we are trying to make everything smaller, more efficient, and less expensive. And that is, all those things together are very, very hard to achieve. And it is a completely kind of brand new, the controls are all brand new, the aesthetics of how the thing looks is all brand new. So essentially that is kind of really, really pushing the boundaries of what we want to do. Because right now, Peak is kind of the leader in hydrogen generating systems, but we need to stay at the lead of that. So all the kind of innovation and ideas people can come up with, we're trying to kind of get these into a system, and that involves a massive amount of testing and validation and just kind of tweaking and prototyping and concepting. I think right now is probably the biggest project I've worked on.
Yeah, well, I think because it's a good question from Harley, because like you said at the
Absolutely.
start, what you're working on is helping change the world, so it must be pretty ambitious. Now, I think we've got time for one more question, and you said that obviously you're working towards something very special and new, which must take a lot of time and stress sometimes, and you've got safety things to go through, but I'm sure you enjoy yourself at work as well. And this question is there any good hydrogen puns or jokes that you see around the office?
That is a very good question, but I've just blanked completely.
Well, I've been put on the spot, yeah.
I know. Next time, I'll think of one.
Next time, we'll bring you back. Right. Well, Ian, I just want to say thank you very much for joining us, and thank you to everyone out there as well for sending in your questions. But now it is all of your turn to come up with your own engineering ideas. Now, remember, and send them to us once you've finished it in class so we can get our certificates sent out to you. Every one of them will be graded and judged by real engineers, and some of Ian and his colleagues are going to be doing the judging as well. So he'll be keeping an eye out for any ideas about hydrogen. Now, don't forget, this interview is going to be uploaded to YouTube if you want to share it with other teachers or rewatch it in full. So just search Primary Engineer to find us. And we've also got a podcast. We're currently halfway through season 2 of the podcast, which is released weekly up until the end of December. So check out our website to learn more about that. That's where we hear from other engineers, teachers, and also pupils who had ideas last year. But for now, I just want to thank everybody for joining us today. A massive thank you again to Ian. And remember, if you were an engineer, what would you do?